Welcome to our lesson on systems of linear equations in two variables. In this video, we're going to have the graphs, the number of solutions, kind of system, and the describing of the slopes and the y-intercepts. This video has two parts. Part 1 is comparing the systems of linear equations in slope-intercept form, and part 2 will be comparing in standard form. Part 1. Comparing systems of linear equations in slope-intercept form. Line 1 is our equation 1 and line 2 is our equation 2. As you can see, the lines or graphs intersect. Therefore, there is exactly one solution or unique solution. That is the intersection of the lines. This system is called consistent and independent. And if you want to compare the slopes and y-intercepts, the slopes here are not equal, and the y-intercepts can be equal or not equal. Next, line 1 is our equation 1, line 2 is our equation 2. As you can see, the lines or graphs are parallel. This means that there is no solution because the lines will never meet. This system is called inconsistent. The slopes here are equal and the y-intercepts are not equal. Equation 1 is our line 1. Equation 2 is our line 2. The lines or graphs coincide. It means that there is infinitely many solutions or many solutions. The system is called consistent and dependent. The slopes and y-intercepts here are both equal. The slopes are equal and the y-intercepts are also equal. This is a special case. As you can see, the lines or graphs are perpendicular. This means that they intersect and form right angles. And as you can see, we have here the right angle symbol. There is exactly one solution or unique solution because they have an intersection or the common point. So that is here. The system is also called consistent and independent. And if you want to compare the slopes and y-intercepts, the slopes are negative reciprocals. The y-intercepts can be equal or not equal. Slopes are negative reciprocals. When you multiply them, the product is negative 1. And since the slopes are negative reciprocals, they are also not equal. For example, 5 is not equal to negative 1/5. Negative 1/5 is the negative reciprocal of 5. 5 is not equal to negative 1/5. For our given, we're going to use the system y equals 3x plus 1 and 3x plus 5y equals 15. For this one, we're going to use the slope-intercept form. Equation 1, we have y equals 3x plus 1. Is this equation in slope-intercept form? Yes, it is. So, the next step is to determine the slope and the y-intercept. The slope here is 3 and the y-intercept is 1. Next, equation number 2, 3x plus 5y equals 15. Is that in slope-intercept form? No, this is in standard form. So we have to rewrite this one in slope-intercept form. That will be subtracting 3x from both sides. So we cancel this because it will be 0 and then bring down 5y. You copy negative 3x plus 15. So you cannot combine these because they are not similar terms. Next, divide both sides by 5. As you can see, we have 5 divided by 5, which is 1. And then you simplify the others. That will be negative 3/5 x plus 3 because 15 divided by 5 is 3. Is y equals negative 3/5 x plus 3 in slope-intercept form? Yes, it is. Now, determine the slope and the y-intercept. The slope here is negative 3/5. and the y-intercept is positive 3. Since we have here the slopes and the y-intercepts, let us compare. We have slope 1 from equation 1, that is 3, and we have slope 2 from equation 2 as negative 3/5. Are they equal or not equal? They are not equal. So the slopes are not equal. How about the y-intercepts? We have B1 for equation 1, this y-intercept is 1, and B2 for equation 2, the y-intercept here is 3. Are they equal or not equal? Not equal. So the y-intercepts are not equal. And now you can describe the graph, determine the kind of system, the number of solution. So that will be the lines or graphs intersect. There is exactly one solution or unique solution. The system is called consistent and independent. And here we have what we got in our comparison of equation 1 and 2. So if we're going to graph this will become, if you want to know the graphing, go back to our lessons on graphs of linear equations. I would recommend using the slope and y-intercept, or using intercepts if you want to graph our systems of linear equations. This is easier if we're going to use the intercepts or the slope and y-intercept. So the graph will be this one. So as you can see, we had the two lines, they intersect, they have the common point. So this is our solution, one solution or unique solution. Next, let us have comparing systems of linear equations in standard form. So we're going to use the standard form. The lines will be the same, the graphs will be the same. We're just going to use the standard form in comparing. So that will be for the first graph, a sub 1 over a sub 2 is not equal to b sub 1 over b sub 2. For the inconsistent or the second graph, we will have a sub 1 over a sub 2 is equal to b sub 1 over b sub 2, which is not equal to c sub 1 over c sub 2. And for the last one, we have a sub 1 over a sub 2 equal to b sub 1 over b sub 2 and equal to c sub 1 over c sub 2. Part 2, comparing systems of linear equations in standard form. So remember, we're going to use the standard form. For equation number 1, y equals 3x plus 1, we know that this is in slope-intercept form. So we have to rewrite this in standard form. That will be subtracting 3x to both sides. So this will be cancelled. Negative 3x plus y equals 1. Since we have here negative sign, we have to multiply both sides by negative 1. So the answer will be 3x minus y equals negative 1. This is the standard form. Now determine your a sub 1, b sub 1, and c sub 1. We use sub 1 because the equation is the first equation, or equation number 1. So a sub 1 here is 3. That is the numerical coefficient of x. B sub 1 is negative 1. So that is the numerical coefficient of y. And then we have c sub 1, that is negative 1. Next, for equation 2, we have 3x plus 5y equals 15. This is already in standard form. So all we have to do is determine our a sub 2, b sub 2, and c sub 2. So a sub 2 is positive 3. B sub 2 is positive 5, and C sub 2 is 15. And then you have to rewrite this in fractional form and then compare whether the answers for A is equal to the answers for B and C and so on. So that will be 3 over 3. So we have 3 here from A sub 1 over A sub 2, which is also 3. We have to determine whether they are equal or not equal. So we have in the numerator, this is our b sub 1 over b sub 2. So as you can see, 3 over 3, we have to determine whether they are equal or not equal. compared to negative 1 over 5 or negative 1/5. And we know that 3 over 3 is 1 and it is not equal to negative 1/5. So that will be this one. This is the first kind of system, consistent and independent. There is exactly one solution. Therefore, when we graph them, they should be intersecting lines. If comparing a sub 1 over a sub 2 to b sub 1 over b sub 2 results to equal, you still have to compare the answer to your c sub 1 over c sub 2. Because whether they are equal or not equal will determine if the system is inconsistent or consistent and dependent. But if you have a sub 1 over a sub 2 compared to b sub 1 over b sub 2, the result is not equal. You don't have to compare it to your c sub 1 over c sub 2 because automatic, the answer is consistent and independent. Thank you. I hope you enjoyed our lesson today. Please like, subscribe, and share.